Hello, welcome to the topic of discussion, Understanding Vapor Pressure Deficit, a VPD, and its impact on plant physiology. Hello, and welcome to this informative session on vapor pressure deficit, commonly known as VPD. Today we'll explore what VPD is, how it influences plant physiology, and why it's crucial for optimizing plant growth. What is vapor pressure deficit, VPD? VPD is the difference between the amount of moisture in the air and the maximum amount of moisture the air can hold when it's saturated. In simpler terms, it's a measure of the air's drying capacity. A higher VPD indicates drier air, which can draw more moisture from plant leaves, while a lower VPD suggests more humid air, reducing moisture loss from plants. How does VPD affect plant physiology? Transpiration rate. High VPD. When VPD is high, the air has a greater capacity to absorb moisture, leading to increased transpiration rates in plants. This means plants lose water more rapidly through their stomata, tiny openings on leaf surfaces. To prevent excessive water loss and potential dehydration, plants may close their stomata, which can limit carbon dioxide intake and subsequently reduce photosynthesis. Low VPD. Conversely, a low VPD indicates that the air is near saturation and can't hold much additional moisture. In such conditions, transpiration rates decrease, which can lead to reduced nutrient uptake and potentially create a microenvironment conducive to fungal diseases due to prolonged leaf wetness. Stomatal behavior. Plants regulate their water loss and gas exchange by opening and closing their stomata. High VPD conditions prompt stomatal closure to conserve water, while low VPD conditions may keep stomata more open, affecting the plant's internal water balance and gas exchange processes. Nutrient uptake. Transpiration plays a vital role in nutrient transport from the soil to various parts of the plant. An optimal VPD ensures a balanced transpiration rate, facilitating efficient nutrient uptake. Deviations from this balance, either too high or too low, VPD, can disrupt nutrient transport, affecting plant health and growth. Optimal VPD range for plant growth. Maintaining an appropriate VPD is essential for healthy plant development. While the optimal VPD range can vary among species and growth stages, a general guideline is seedlings and clones prefer a lower VPD to reduce water loss and stress. Vegetative stage, moderate VPD supports robust growth and transpiration. Flowering stage, slightly higher. A VPD can enhance nutrient uptake and development. It's important to note that these are general recommendations, and specific VPD requirements may vary based on plant species and environmental conditions. Monitoring and managing VPD. To effectively manage VPD, measure temperature and humidity. Use reliable sensors to monitor ambient temperature and relative humidity, as VPD is derived from these parameters. Adjust environmental controls. Utilize humidifiers, dehumidifiers, heaters, or cooling systems to modify the growing environment and maintain the desired VPD. Consult VPD charts. These charts help correlate temperature and humidity to VPD values, assisting in achieving optimal conditions for specific plant species. By carefully monitoring and adjusting VPD, growers can create an environment that promotes healthy growth, maximizes photosynthesis, and enhances overall plant performance. Understanding and managing vapor pressure deficit is crucial for successful plant cultivation. By maintaining an optimal VPD, you can ensure that your plants thrive, leading to better yields and healthier crops. Remember, achieving the right balance requires continuous monitoring and adjustments tailored to understanding and managing vapor pressure deficit is crucial for successful plant cultivation. By maintaining an optimal VPD, you can ensure that your plants thrive, leading to better yields and healthier crops. Remember, achieving the right balance requires continuous monitoring and adjustments tailored to your specific plant's needs. Thank you for joining this session on VPD and its significance in plant physiology.